Hey everybody, welcome to a math video. So I'll be talking about number sets in this video. So before you can actually get into the operational stuff, you have to understand the basics first. So let's go through this. I'm hoping it won't be too long of a video. So here we go. So this is what we'll be covering today: number sets and categorizing numbers into number sets. Okay, so there's 6 main categories of number sets. You can see here: natural numbers, whole numbers, integers, not integers. It's the G in this case is pronounced as a J, so it's an integer. Rational numbers, irrational numbers, and real numbers. Okay, so we'll go through all of these one at a time. Okay, so first up is natural numbers. So these are traditionally known as your counting numbers, and they start at 1 and they continue up to positive infinity. And it's important to note that natural numbers don't include decimals or fractions. So you go 1, 2, 3, 4, 5, 6, all the way up, as far as you can go until you get tired or you just get bored. Okay, so natural numbers begin at 1. That's important to remember. Okay, so next we got whole numbers. So whole numbers starts at 0 and then goes up to positive infinity. So whole numbers includes natural numbers. The difference between natural numbers and whole numbers is that whole numbers includes 0. Okay, 0. And it's important to remember also that 0 has no sign at all. It's not positive, it's not negative, it's just 0. There's nothing. Okay, so whole numbers, 0, 1, 2, 3, 4, 5, 6, all the way as far as you can go. And just like natural numbers, decimals and fractions are not included. Okay. So next up we have the integers. So integers, by definition, are your positive and negative whole numbers. Okay, so they start at negative infinity and they go all the way to positive infinity. So just as an example, I'm going to start at something a little bit smaller, so like negative 10, but just know that everything else past negative 10 is going to be way smaller. And remember, in negative numbers, the larger the value of a negative, the smaller it actually is. So, for example, I chose to start at negative 10, but if I start at negative 100, negative 100 would be smaller because it appears further left on the number line if you're doing a number line. Okay, so negative 10, I'm going to start there, just to keep it simple. And because I don't want to make this video way too long or anything. So negative 10, negative 9, negative 8, ... 0, 1, 2, 3, 4, and so on and so on and so on. Okay, so just like with whole numbers and natural numbers, decimals and fractions are not included. So far we're just dealing with whole numbers, no decimals, no fractions. Okay, so next up we have the rational numbers. So rational numbers are going to be easier to identify when you convert them to decimals. So if you have a fraction, you always want to simplify it if you can, and then convert it to a decimal if you haven't been able to simplify it to either a natural number, whole number, or an integer. Okay, so we got some examples here. So in rational numbers, they either terminate or they repeat. Okay, so here's what I mean by that. So if terminate, that means once you convert it to a decimal, it ends at some point. Okay, so a good example, the easiest one that everyone likes to use, the 1/2. So 1/2 as a decimal is 0.5, and it stops there. There's nothing past it, so it just ends. Right, so it terminates. We call that terminates. Right, so another, just a big word for end. Okay, the other one is repeats. So if you reduce a fraction and then you convert it to a decimal and it repeats, it's also a rational number. And the example that people like to use for this is 1/3 because it's simple also. So 1/3 as a decimal it changes to 0.333333 and so on. It's the same number repeating. So this also holds true for repeating groups of numbers. Like, for example, 1/7. That'll convert to a repeating decimal that has like a larger group of numbers that repeat, but it definitely repeats. That you see the pattern. Okay, so rational numbers falls into one of these two categories. Okay, so they either terminate or they repeat, not both at the same time. That's an important distinction to remember for rational numbers. Okay, so next we have irrational numbers. So irrational numbers must fall in these two categories. They have to happen at the same time. They don't terminate and they don't end. Okay, so rational numbers, remember, they terminate or they end, one or the other. For irrational numbers, both of these have to hold true. So they don't end and they don't repeat. I'm sorry, that's supposed to be not repeat, not end. So they don't terminate, they don't end, and they don't repeat. So I'll fix that later. So an example that a lot of people like to use is pi. Okay, so pi to so many decimals, 3.14159263, and so on and so on. But the important thing here is that there's no group of numbers that repeats. So it has to repeat consistently for it to be considered a repeating decimal. So if it went 3.141514151415, for example, then that's a repeating group. Now make it a rational number. But since no groups of numbers repeat consistently, as you can see here, that makes pi an irrational number. Okay, and the last category is real numbers. So real numbers is actually easy because any number that falls into these other categories, all the other ones that we talked about earlier, makes it also a real number. So when you're classifying these numbers, you also got to remember that they also fall under the real number category. It's something important to remember. Okay, so here are some examples. I'll walk through these with you. We can classify all these numbers, okay? So the first one, 14, we're going to classify 14, and they're going to fall into more than one category, and that's okay, because you want to list all the categories that this particular value falls into. Okay, so 14 is a natural number. It's also a whole number. It's also an integer. And because it terminates as a decimal, it makes it also a rational number. And since it fell into one of those 5 categories, it's also a real number. Okay, so this falls into 5 number categories. Okay, and so number 2, negative 14. So negative 14 is not a natural number, because natural numbers are your counting numbers, which does not include any negatives. It's not a whole number, because whole number consists primarily of natural numbers. But it is an integer because it is negative. It also terminates, which makes it a rational number. And since it fell into those 2 categories, it's also a real number. I hope that wasn't too confusing. So now number 3, 27/3. So if possible, you do want to simplify. So 27/3 will simplify into 9. Okay, so 9 is a natural number. Since it's a natural number, it also falls into the whole number category. So it's a natural number, whole number, and it's also an integer. And since it terminates as a decimal, it's also a rational number. And since it fell into those 4 categories, it's also a real number. Alright, so now number 4 here, 28/3. Now 28/3 does not simplify into, well, it doesn't simplify nicely. So it's not a natural number, it's not a whole number, and it's not an integer. However, it does repeat as a decimal. That makes it a rational number. So, since it's a rational number, it also makes it a real number. And one thing I forgot to mention earlier is that a number cannot be rational and irrational at the same time. It's either one or the other. If a number is rational, it's rational. If a number is irrational, it's irrational. But they can't be both at the same time either. Okay, so that being said, number 5, square root of 2. So square root of 2 does not simplify into a non-decimal number. As a decimal, it doesn't terminate and it doesn't repeat, which automatically makes it an irrational number. And since it's an irrational number, that also makes it a real number. So square root of 2, irrational, real. That's the only two categories it falls under. Okay, and number 6. So number 6, 0. So 0 is not part of the natural numbers category, so it's not one of those. However, it is a whole number, because whole numbers start from 0. It is an integer. It is rational, because as a decimal, it does terminate. And since it fell into those 3 categories, it's also a real number. Alright, pretty simple. Okay, so to sum it all up. So natural numbers begin at 1 and go to positive infinity. These are commonly thought of as your counting numbers. Whole numbers are like your natural numbers. The only difference is it starts from 0 and goes to positive infinity. Integers start from negative infinity and go to positive infinity. And all these 3 categories do not include decimals or fractions. Okay, so just, like -2, 0, 5, 600, those types of numbers. Okay, now rational numbers are easier to identify as decimals. So if you have a fraction that doesn't simplify, convert it to a decimal. If it doesn't terminate, if it terminates or if it repeats, it's a rational number. Okay, one or the other of those 2 categories. Either it ends or it doesn't end. But if it doesn't end, it has to repeat a group of numbers or a number in order for it to be rational. Now, irrationals, again, you want to convert this to a decimal, and as a decimal, it doesn't terminate and it doesn't repeat. So it has to fill those two rules together at the same time. So the example I gave earlier was pi, because there's no group of numbers that repeats. It just keeps going, doesn't end. Right? Okay, and real numbers. So I also mentioned that if a number that you're categorizing falls into one of the previous 5 categories, it's also a real number. And I did point out that a number cannot be rational and irrational at the same time. It has to be either rational or irrational, one or the other. Alright guys, well that's it for this mini lecture. Thanks for tuning in, and I hope you learned something. So stay tuned for my next videos, and take care.